A-level physics, and the name of the topic is rectangular coordinate system. So in rectangular coordinate system we use the three coordinate system, and that is ax, ay, az. Ax is the coordinate system, the x direction, while the ay coordinate is in the y direction and az coordinate is in the z direction. So before going to rectangular coordinate system, let's discuss first the scalar product. So let's first define it, that what is meant by the scalar product. So scalar product, or you can say that dot product, it's also called scalar product or dot product. So let's first define it. So scalar product may be defined as such type of product which result in a scalar quantity is known as scalar product or dot product, like work, so these two are the vectors force and displacement. So force and displacement are the vector quantity, and when we do the dot product or scalar product, so it gives us the work, which is a scalar quantity. Now let's similarly electric flux, which is also scalar quantity because it is the dot product of electric field and area. These two are vector quantity. So when we do the dot product in between these two vector quantity, so it gives us the electric flux, which is also a scalar quantity. Similarly, kinetic energy is also a scalar quantity because it is the product of dot product of two vector quantity. Similarly, power, which is equal to force velocity. So these two are also vector quantity, and their dot product result in a scalar quantity. Like also, if you see the magnetic flux, so these two are also vector quantity, and their dot product give us a scalar quantity. Now let's explain this dot product further from graph. Like let's we have two vector A is represented by this symbol, and let's we have another vector which is B, and that is represented by this symbol. Let's see, this is my vector A, and let's we have another vector which is vector B, and that is in this direction. So divide this vector into its component. So this will be their Bx component, and this will be their By component. So the scalar product may be defined as magnitude of first vector to the component of second vector, and that component must be in the direction of first component. My first component is A and my second component is B. So product of these two vectors can be written like this: A dot B. And as I defined it, that it is the product of magnitude of first vector. So this is my first vector and this is my second vector. So it is the magnitude of first vector and the component of second vector in the direction of first vector. So here Bx component is such a component of second vector which is in the direction of first component. So here we taken the Bx. So as you know that bx is equal to magnitude of b cos theta. Let's here the angle between these two vectors is theta. So you can write it such like that a dot b will be equal to magnitude of a, and putting the value of bx, so we will get magnitude of b cos theta. Or you can say that the dot product will be equal to a b cos theta. So this is the second definition of dot product. Now let's take on this b vector as my first vector and this a vector as my second vector. So the dot product can be written like b dot a. So as I defined it, that it will be the dot product of these two vectors will be equal to the magnitude of first vector. So here this is my first vector and this is my second vector. So it is the magnitude of the first vector. So the magnitude of first vector can be written like this, and the component of second vector in the direction of first vector. So let's resolve or divide this vector a into its component. So when we divide this, so this will be my ax component and this will be my ay component. So when I divide this vector into its component, so this will be their ax component and this will be their ay component. So here if you see that the ax component of this vector is such a component which is in the direction of b vector. So here we will write ax as ax is equal to magnitude of a into cos theta. So this will be equal to magnitude of b, magnitude of a cos theta. Just putting the value of ax, this value in this equation, so you will get this equation. So my b dot a or scalar product will be equal to ab cos theta. So if you see here, let's say this is my equation 2 and this is my equation 1. So if you see to equation 1 and equation 2, so you can say that a dot b is equal to b dot a. Or you can say that the scalar product or dot product obey the commutative law. Let's take on this equation and solve it for different angle. Let's I have theta and that is equal to 0. It means that if my vector A is in this direction, my vector B is also in this direction. So the theta will be equal to 0. So putting the value of theta is equal to 0 in equation 1. So from here we will get such like equation A B cos 0 is cos 0 is equal to 1. So A dot B will be equal to AB. Now if theta is if theta is equal to 90, so this is my vector A, so the vector B will be in this direction, so the theta will be equal to 90. So the equation 1 will be A dot B is equal to A B cos 90 as cos 90 is equal to 0, so A dot B is equal to 0. Similarly, if theta is equal to 180 degree, so putting the value of theta in equation 1, so you will get A dot B will be equal to A B cos 180 degree as cos 180 degree is equal to minus 1, so A dot B will be equal to minus A B. Similarly, if theta is equal to 270, so you will get the dot product is equal to 0, because if you putting the value of theta in equation 1, so you will get the value and that is equal to 0. So this is all about the scalar product.